Dear students, please open your textbook before you start listening. Underline important lines and mark difficult words. Happy listening and happy learning by Rana Admane. Thank you. Textbook for Class 10th. Subject Science. Chapter 1. Chemical Reactions and Equations. Page number 1. Consider the following situation of daily life and think what happens when. Point 1. Milk is left at room temperature during summer. Point 2. An iron tawa or pan or nail is left exposed to humid atmosphere. Point 3. Grapes get fermented. Point 4. Food is cooked. Point 5. Food gets digested in our body. Point 6. We respire. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we came to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Now, activity 1.1 with figure 1.1. In figure 1.1, burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Now starting activity 1.1. Caution. This activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 cm long by rubbing it with sandpaper. Hold it with a pair of tongues. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? Page 2. You must observe that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Now activity 1.2 with figure 1.2. In figure 1.2, formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Now starting activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe from the now activity 1.3. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this, as shown in figure 1.2. Question. Handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Number 1. Change in state. Number 2. Change in color. Number 3. Evolution of a gas. Number 4. Change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representations in this chapter. 1.1 Chemical Equations. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen is reactant is equal to magnesium oxide, that is product. The substance that undergo chemical change in the reaction 1.1. Magnesium and oxygen are the reactants. The new substance is magnesium oxide formed during the reaction as a product. A word equation shows change of reactant to product through an arrow placed between them. The reactants are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS with a plus sign between them. The arrowhead points towards the product and shows the direction of the reaction. 1.1.1 Writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 is equal to MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. 1.1.2 Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9th. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the element present in the products of a chemical reaction has to be equal to the total mass of the element present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid is equal to zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 is equal to ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow by the below table. In one column, elements, second column, number of atoms in reactants, third column, number of atoms in products. For the element zinc, number of atom in reactant is 1, number of atom in product is 1. For hydrogen, number of atom in reactant 2, number of atom in product 2. Element 3, sulfur, number of atom in reactant 1, number of atom in product 1. For oxygen, number of atom in reactant 4, number of atom in product 4. As the number of atom of each element is the same on both sides of the arrow. 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O is equal to Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe plus H2O is equal to Fe3O4 plus H2. 1.5. Step 2. List the number of atoms of different element present in the unbalanced equation by below table. This table are of 3 columns. Elements, number of atom in reactants, number of atom in products. For ferrous, number of atom in reactant 1, number of atom in product 3. Hydrogen, number of atom in reactant 2, number of atom in product 2. Oxygen, number of atom in reactant 1, number of atom in product 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms. Atoms of oxygen. Initial first in H2O, 4 in Fe3O4. Second, to balance 1 into 4 in product 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compound or elements involved in the reactions. For example, to balance oxygen atom, we can put coefficient 4 as 4H2O and not H2O4 or H2O4. Now the partly balanced equation becomes Fe plus 4H2O is equal to Fe3O4 plus H2. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atom in the partly balanced equation. To equalize the number of hydrogen atom, make the number of molecules of hydrogen as 4 on the RHS. By below table, atoms of hydrogen in reactant and in product. For initial, 8 in 4H2O, in product twice in H2. Second, to balance, in reactant 8, in product 2 into 4. The equation would be Fe plus 4H2O is equal to Fe3O4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Atom of iron in reactant in product. In first column, initial. In second column, 1 in Fe. In third column, 3 in Fe3O4. In second line, to balance. In reactant, 1:3. In product, 3. To equalize Fe, We take 3 atoms of Fe on the LHS. Thrice Fe plus 4H2O is equal to Fe3O4 plus 4H2. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. Thrice Fe plus 4H2O is equal to Fe3O4 plus 4H2. It is balanced equation. The number of atoms of element on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation 1.9. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactant and product are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notation gram, liter, AQ, and S, respectively. The word aqueous, AQ, is written if the reactant or product is present as a solution in water. The balanced equation 1.9 becomes thrice Fe plus 4H2O gas is equal to Fe3O4 S plus 4H2 gas. 1.10. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, COG plus twice H2 is equal to on arrow 340 atm is equal to CH3OH 1.11. 6CO2 AQ plus twice H2O L on arrow sunlight and chlorophyll is equal to C6H12O6 AQ plus 6O2 AQ plus 6H2O L. Equation 1.12. Using these steps, can you balance equation 1.2 given in the text earlier? Now question 10. Question number 1. Why should a magnesium ribbon be cleaned before burning in air? Question 2. Write the balance equation for the following chemical reactions. First one, hydrogen plus chlorine is equal to hydrogen chloride. Second, barium chloride plus aluminium sulfate is equal to barium sulfate plus aluminium chloride. Third one, sodium plus water is equal to sodium hydroxide plus hydrogen. Question number 3. Write a balanced chemical equation with symbols for the following reactions. 1. Solution of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. Second, sodium hydroxide solution in water react with hydrochloric acid solution in water to produce sodium chloride solution and water. Thank you.